Hello everyone, myself Ashutosh Sadaya, and in this video we are going to learn about motherboard form factors, RISC versus CISC and chipset. So let's first start with motherboard form factors. So first is, what is form factor? When we say form factor is a specification of physical dimension in layout and other explicit information that helps ensure the hardware works with products that support that form factor. Form factors help prevent incompatibilities between multiple hardware manufacturers. And in case of motherboard, what is form factor is that motherboard has different types of size, different types of layout and different types of use. Combining all three, you can make motherboard form factors. So first form factor is AT. AT form factor is released with IBM PC AT in 1984 and its dimensions are 12 by 11 to 13 inch. And it is also called full AT motherboard. It was popular during Intel 386 microprocessor era and it is superseded by ATX form factor. The next form factor is baby AT. It is smaller compared to AT motherboard. So its dimensions are 8.5 inch to 10 to 13 inches. AT and baby AT both has same functionalities, but it became popular due to its small size. The next motherboard is ATX. ATX means extended, advanced technology extended. Intel released this form factor in 1996. Its dimensions are 12 inch by 9.6 inch. It is very popular form factor which is used currently in some of the desktop computers. The next form factor is LPX, low profile extended. It was developed by Western Digital and its dimensions are 9 inch by 11 to 13 inch. Based on design by Western Digital, it allows smaller cases than the AT standard by putting the expansion card slots on a riser card. By using this type of form factor, you can develop smaller cases so that your overall computer size becomes smaller. Then the next motherboard is NLX, new low profile extended. Its dimensions are 8 to 9 inches by 10 to 13.6 inches. It is developed in 1997 and it has also incorporated a riser card for expansion slots, but it never became popular. The next is BTX, Balanced Technology Extended. It was released by Intel in 2004. Its dimensions are 12.8 inches by 10.5 inches. It was released as a successor to ATX in early 2000. The next is Nano ITX. It was released by VIA in 2003. Its dimensions are 4.7 by 4.7 inch. It was specifically targeted at smart digital entertainment devices like PVRs, set-top box, media centers and car PCs and other thin devices. And the next form factor is DTX. It was released by AMD in 2007 and its dimensions are 8 inches by 9.6 inches. It was designed for smaller computers like home theaters. The board allows 2 expansion slots and DTX motherboard are backward compatible with ATX form factor, so you can fit DTX motherboard in ATX supported cabinets. So that's all for motherboard form factors. The next topic is chipset. The specialized chips on computer's motherboard or expansion card are called chipset. The chipsets are a bunch of intelligent controller chips. It controls communication between processor and external devices. Generally, chipset contains more than one chip into single chip. Current manufacturers of chipsets are NVIDIA, ATM, VIA Technologies, SIS, Intel and Broadcom and etc. Most of the manufacturers include floppy disk control circuitry, IDE controller, IO controller and controller for serial port, USB port, etc. Now let's see the diagram of chipset. As you can see from the diagram, that chipset is divided into two parts, Northbridge and Southbridge. The Northbridge part is directly below the CPU and Southbridge part is directly below the Northbridge. But Southbridge is connected to CPU via Northbridge. So as you can see from the diagram, that Northbridge is connected to AGP and RAM. Northbridge or a host bridge is a microchip on some PC motherboards and is connected directly to the CPU and responsible for the tasks that require higher performance. The Northbridge is usually paired with Southbridge, also known as I/O controller hub. In system where they are included, these two chips manage communications between CPU and other parts of motherboard and create the core logic chipset of PC motherboard. Northbridge typically handles communication among CPU, RAM and AGP. In some cases, AGP is replaced by PCI Express cards and Northbridge is also connected to Southbridge. Some Northbridge also connect integrated video controllers, also known as graphic and memory controller hub. Because different processor and RAM require different signaling, a given Northbridge will typically work with only one or two classes of CPU and generally only one type of RAM. The next is Southbridge. Southbridge is one of the chips in the core logic chipset on the personal computer motherboard, other being the Northbridge. The Southbridge typically implements the slower capabilities of motherboard in Northbridge-Southbridge chipset computer architecture. The Southbridge can usually be distinguished from Northbridge by not being directly connected to CPU rather than Northbridge ties the Southbridge to the CPU. Through the use of controlled integrated channel circuitry, the Northbridge can directly link signals from I/O units to the CPU for data control and access. A Southbridge chipset handles all of computer's I/O functions such as USB, audio, serial, the system BIOS, ISF bus, interrupt controller and IDE channels. So that's all for chipset. The next topic is CISC versus RISC. In GTU exams, the question is asked that differentiate CISC versus RISC. So what is CISC and what is RISC? So full form of CISC is Complex Instruction Set Computing. Most of the PCs use CPU based on this architecture. For instance, Intel and AMD CPUs are based on CISC architecture. Typically, CISC chips have a large amount of different and complex instructions. The philosophy behind it is that hardware is always faster than software. Therefore, one should make a powerful instruction set which provides programmers with assembly instruction to do a lot with short programs. And another is RISC. Full form of RISC is Reduced Instruction Set Computing. RISC chips evolved around mid-1980s as a reaction to CISC chips. Apple uses RISC chips based computers. Most people mostly use compilers which never use complex instructions. Therefore, fewer, simpler and faster instructions would be better than large and complex and slower CISC instructions. However, more instruction needed to accomplish a task. Finally, it is easier to write powerful optimized compilers since fewer instructions exist. So, let's see the difference between CISC and RISC. In CISC computers, emphasis on hardware, and in the RISC-based computers, emphasis on software. In CISC-based computer, more emphasis is on hardware, and in the RISC-based computers, more emphasis is on software. CISC includes multi-clock and complex instructions, while RISC includes single clock and reduced instructions only. Memory-to-memory load and store are incorporated in instructions. For CISC and for RISC, register-to-register load and store are independent instructions. In CISC, the code size is smaller and clock cycle are higher. In the RISC, code size is larger and clock cycle are lower than CISC. In CISC, transistors are used for storing complex instructions, while in RISC, more transistors are spent on memory registers. So that's it for today's video. Hope you have understood motherboard form factors, chipset and difference between RISC and CISC. Thank you.